Dear students, today we are going to discuss derivatives. Now the credit of development of calculus definitely goes to two great mathematicians, Newton and Leibniz, but there are many mathematicians who have contributed. Uh, Michael Rolle from France and Joseph Lagrange for Italy are the two important mathematicians. Now in mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus, which is the other one. The other is integral calculus. It studies the area beneath a curve. In physics, the derivative of the displacement of a moving body with respect to time is the velocity of the body. That is, velocity is rate of change of displacement, and rate of change of velocity with respect to time is called as acceleration. And what is negative acceleration? It is called as deceleration. The derivative of the momentum of a body with respect to time equals the force applied to the body. If you rearrange this statement, you get F equal to ma, which is an important equation associated with Newton's second law of motion. As derivative measures the rate of change, it has application in all the fields. The reaction rate of a chemical reaction is again a derivative. In operation research, derivatives determine the most efficient ways to transport material and design factories. Now we define derivative. If x and x plus delta x belong to the domain of the same function f and limit f of x plus delta x minus fx upon delta x as delta x tends to 0 exist, then the function f is said to be differentiable or derivable at x, and this limit is called the derivative of the function f at x, which is denoted by f dash of x, or later we are going to discuss Leibniz notation. So as per that notation, it is ddx of f of x. So what is f dash of x? That is derivative of the function. It is value of the limit f of x plus delta x minus fx upon delta x as delta x tends to 0. It is convenient to use the letter h to denote the increment delta x. So we can write this as f dash of x equal to limit f of x plus h minus fx upon h as h tends to 0. Now the process of finding the derivative of a function is called as differentiation. Finding the derivative of a given function by using this definition is referred to as finding its derivative from the first principle. Now what do you mean by derivative at a point? If f is a function and a plus h belong to the domain of this function, then the limit given by limit f of a plus h minus fa upon h tends to 0, if it exists, then it is called as derivative of the function f at x equal to a, and it will be denoted by f dash of a. So what is f dash of a? It is value of the limit f of a plus h minus fa upon h as h tends to 0. Now this is an important notation for derivative suggested by German mathematician Leibniz. See, what is delta y by delta x? We can show that it is f of x plus delta x minus fx upon delta x. This ratio is called an incrementary ratio, and f dash of x is what? Limit f of x plus delta x minus fx upon delta x as delta x tends to 0. That is limit delta y upon delta x as delta x tends to 0. Leibniz denoted the limit on right hand side by what? By dy dx, that is ddx of y. So this is called as Leibniz notation for derivative. Thus what is dy dx? Dy dx is limit delta y upon delta x as delta x tends to 0. provided this limit exists. This means that the derivative of the function y equal to fx can be denoted as f dash of x or dy dx, or it can also be denoted as y1 or y dash. Now this is the most important part, that is geometrical interpretation of derivative. First I will tell you the interpretation and then its proof. Geometrically, f dash of a, that is dy dx at x equal to a, represents the slope of tangent to the curve y equal to fx at a point x equal to a on the curve. I repeat this statement. Geometrically, f dash of a, that is derivative of y equal to fx at x equal to a, represents slope of tangent to the curve at a point x equal to a on the curve. Now I will explain the proof. See the diagram. Let P be the point x equal to a on the curve y equal to fx, that is x coordinate of the point P is a. Now this point lies on the curve y equal to fx. So it will be the y coordinate. It will be f of a. So P has coordinates a, f of a. Take a point Q, a plus h, f of a plus h on the curve. Then what will be the slope of secant PQ? Slope is nothing but difference in y coordinates upon difference in x coordinates. That is f of a plus h minus fa upon a plus h minus a, that is nothing but h. Now as q tends to p along the curve, the limiting position of the secant pq is the tangent to the curve at the point p, that is at the point x equal to a, and the slope of the tangent at p is also called as gradient of the curve. This word is important, gradient of the curve, in this case at which point? At point p. Now as q tends to p along the curve, h will tend to 0. Therefore gradient of the curve at p is nothing but slope of tangent pt, which is nothing but, I can say, limit of slope of secant pq as q approaches p, that is limit of f of a plus h minus f of a upon h as h tends to 0. You will notice that this is nothing but f dash of a. So the conclusion is f dash of a represents the slope of the tangent to the curve y equal to fx at a point a, f of a. Now what will be the equation of this tangent? To get the equation of tangent line, we must know one point on the line, which we know, a, f of a, because tangent is drawn at this point only. We should know the slope also. F dash of a is the slope. So what is the equation? Y minus y1 equal to m, that is slope, into x minus x1, that is y minus f of a, equal to f dash of a into x minus a. Now if you draw perpendicular at P, point of contact, that is the point at which tangent is drawn to the curve, then that perpendicular is called as normal to the curve. Now can you tell me what will be the equation of normal? See, normal also passes through this point only, a, f of a. You should know that product of slopes of two perpendicular lines is -1. So if slope of tangent is f dash of a, slope of normal, which is perpendicular to this, will be what? -1 upon f dash of a. So equation of normal is y minus f of a equal to -1 upon f dash of a into, in bracket, x minus e. Now this is physical significance of a derivative. You will use this in physics. Suppose a function given by y equal to fx is differentiable at x equal to a. Means what? Its derivative exists at x equal to a. If x changes from a to a plus h, then f of x will change from f of a to f of a plus h. Thus f of a plus h minus f of a is the change in fx corresponding to the change h in x. Now what is the average rate of change? It is f of a plus h minus f of a upon h. Okay. Now if you take limit as h tends to 0, you get what? Limit f of a plus h minus f of a upon h as h tends to 0. But this is nothing but f dash of a. This exists. Why? Because initially only I have told that f is a differentiable function at x equal to a. Now it is called instantaneous rate of change of the function at x equal to a. I repeat, it is called instantaneous rate of change of the function f at x equal to a. Hence we can say that the derivative f dash of a measures the rate of change of f at x equal to a. Thus, the derivative of a function is a rate measurer of the function. That is why derivative is used in all fields of life. I have given this example many times. In economics also, we have to measure the rate of change of demand with respect to supply. So in that case also, we have to use derivative. Now, let a particle be moving along a straight line such that its displacement s at any time t is expressed as a function of t, say s equal to f of t. The rate of change of displacement s with respect to time t is what, as per Leibniz notation, ds dt equal to f dash of t. Now this is called as velocity v of the particle at time t. If you find derivative of the velocity with respect to time, you get acceleration. So acceleration is nothing but dv dt and velocity is nothing but ds dt. Okay, now we are in a position to solve sums on derivatives. Using first principle, find the derivative of the following functions. The first one, 3x square plus 4. Let f of x be 3x plus 4. So what is f of x plus h? It is 3 into x plus h square plus 4. Now open the bracket, simplify. You get 3x square plus 6xh plus 3h square plus 4. Substitute the values. You will notice that from numerator, I am explaining this step. From numerator, you can take h common to get 6x plus 3h. Right? Can we cancel h? Yes, h only tends to 0, not equal to 0. So it is what? Limit of 6x plus 3h as h tends to 0. Take the limit. To take the limit means to replace not x but h, because variable is h. H is a small change. It approaches 0. So 6x plus 0, that is 6x is the derivative of which function? 3x square plus 4. Now this is another function, 1 upon 2x plus 3. Let fx be 1 upon 2x plus 3. What is f of x plus h? F of x plus h is value of the function f at x plus h. So replace every x by x plus h. Previously it was 2x plus 3 in the denominator. Now it will be 2 into in bracket x plus h plus 3. Open the bracket and so on. So what is difficult? Derivative is not difficult. Finding LCM for subtracting one fraction from the other, that is difficult. So if you can subtract fractions, then you will notice that you have got this function. Now cancel h. Now we are in a position to take the limit. To take the limit means to replace every h by its limiting value. Now here you will notice that minus 2 upon 2x plus 3 is taken outside the limit. Is it correct? Yes, because h tends to 0. X remains unaffected. So we can write it outside the limit. Now put h equal to 0. Simplify. You will notice that what is derivative of 1 upon 2x plus 3? Minus 2 upon 2x plus 3 square. Now this is again interesting function. Root sin x. Let fx be root sin x. So what is f of x plus h? It will be root of sine of x plus h. Logic is very simple. Previously it was square root of sine x. Now it will be square root of sine of which angle? X plus h. Substitute the values because this is the definition of derivative. Now you have to realize that you have to rationalize. Rationalizing numerator, you get what? A minus b into a plus b is a square minus b square. Denominator will be h into this. Now can we take the limit? To take the limit here, I have to replace h by 0. But in that case, denominator becomes 0, which is not correct. So we are supposed to use which formula? Sin A minus sin B in the numerator. So I get this and so on. Angle must be fully repeated. So though denominator is h, I write h by 2, right? Because angle is h by 2. So this 2 is utilized. You can read this solution. So I have made two parts of this. In the first part, how to take limit? Just by putting h equal to 0. And you know that this is standard trigonometric limit. Its value is 1. So what is the final answer? It is cos x upon 2 root sine. Now before we discuss the rules of differentiation, let us revise standard formulae. Now which functions are called as standard functions? Functions like x raised to n, power function, then exponential functions like e raised to x, a raised to x, logarithmic function, 6 trigonometric functions, 4 inverse trigonometric functions. We call them as standard functions. Now derivative of x raised to n is n into x raised to n minus 1. Observe that in x raised to n, base is variable, index is constant. So how to remember this? Derivative of x raised to n is n into x raised to n minus 1, that is index into x raised to index minus 1. So if you use this formula, what will be derivative of 1 upon x? It will be minus 1 upon x square. What will be derivative of root x? 1 upon 2 root x. Now we know that derivative is a rate measurer. What will be derivative of constant? Constant is 1 which does not change. So derivative of any constant will be 0. Derivative of root x with respect to x will be 1 upon 2 root x, right? But derivative of root a with respect to x will be 0 as root a is a constant. Similarly, we have derivative of sin x as cos x, derivative of cos x as minus sin x, derivative of tan x as sec square x, derivative of cot x as minus cosec square x, derivative of sec x is sec x into tan x, derivative of cosec x is minus cosec x into cot x. What is derivative of a raised to x? It is a raised to x log a. See the difference? In a raised to x, base is constant and index x is variable. What will be e raised to x? It will be e raised to x log e, but log e is 1. In calculus, base of logarithm is e only. So log of e to the base e is 1. So it is just e raised to x. What is derivative of log of 1 upon x? It will be, what will be derivative of log x? It will be 1 upon x. Now these functions are important, especially in physics. You require derivative of sine inverse x and tan inverse x. What is derivative of sine inverse x? It is 1 upon root 1 minus x square. Derivative of cos inverse x minus 1 upon root 1 minus x square. What is derivative of tan inverse x? It is 1 upon 1 plus x square. Derivative of cot inverse x is minus 1 upon 1 plus x square. Derivative of sec inverse x is 1 upon x into root x square minus 1. What is derivative of cosec inverse x? It is minus 1 upon x into root x square minus 1. Now we remember these using Leibniz notation. We say ddx of k, that is constant, equal to 0. ddx of x raised to n is nx raised to n minus 1. ddx of 1 upon x is minus 1 upon x square. ddx of root x is 1 upon 2 root x. ddx of sin x is cos x. ddx of cos x minus sin x. ddx of tan x sec square x. ddx of cot x minus cosec square x. ddx of sec x tan x. ddx of cosec x minus cosec x cot x. ddx of a raised to x log a. ddx of e raised to x ddx of log x 1 upon x. Just an observation, trigonometric function, whether original or inverse, you will notice that if spelling starts with C, derivative is negative. This is just an observation. This cannot be a rule, but this is an observation. Cos has derivative minus sine, cot has minus cosec square x, cosec has minus cosec into cot, then cos inverse has minus 1 upon, cot inverse minus 1 upon 1 plus x square, and so on. Note that every time you need not differentiate the given function with respect to x. For example, if you want to differentiate with respect to t, where t is you can say time, then what will be ddt of sin t? Same, cos t. ddt of log t will be what? 1 upon t, and so on. Now this is an important part, rules of differentiation. If u and v are differentiable functions of x and k is a constant, what do you mean by differentiable functions? By differentiable functions we mean their derivatives exist. The first rule is simple one. If y is u plus v, then dy dx is what? Du dx plus dv dx. That is derivative of sum is what? Sum of derivatives. Second will be derivative of difference will be difference of derivatives. Now let us discuss fourth part, because third one is corollary of fourth. See, derivative of product is not product of derivatives. Then what is derivative of product? If y is u into v, then dy dx is first function into derivative of second plus second function into derivative of first. So derivative of product is not the product of derivatives. It is first into derivative of second plus second into derivative of first. Now the third one is corollary of this. If one of the two functions is constant, say k, then what is y equal to ku? It is basically, as per product rule, first function k into du dx plus second function u into derivative of k. Derivative of any constant is 0, and that is why it is not written. So how to remember result number 3? Derivative of constant into function is that constant into derivative of function. Now result number 5 is again corollary of result number 4. Instead of 2, if there are 3 functions, you have to use the same logic. Now the last result is again very important. It is called as quotient rule. If y is u upon v, then what is dy dx? It is v du dx minus u dv dx upon v square, provided v not equal to 0. So how will you remember this? Derivative of quotient is denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square. So result number 4 and 6 are very important. I repeat, derivative of product is not product of derivatives. Derivative of product is first into derivative of second plus second into derivative of first. Imagine derivative of product as product of derivatives. In that case, derivative of each function will be 0. I repeat the statement. If derivative of product is product of derivatives, then derivative of each function will be 0. I will explain. We know that derivative of sin x is cos x, right? Now can I write sin x as 1 into sin x? Yes, I can. If derivative of product is product of derivatives, then what will be derivative of sin x? That is derivative of 1 into sin x. It will be derivative of 1, which is 0, into derivative of sin x, which is cos x, but 0 into cos x is nothing but 0. Take any other function. Derivative of e raised to x, e raised to x. I can write e raised to x as 1 into e raised to x. So in this case also, if derivative of product is product of derivatives, answer will be derivative of 1, which is 0, into derivative of e raised to x, which is e raised to x, but 0 into e raised to x is 0. So this shows that derivative of product is not the product of derivatives. Now simple examples. Differentiate the following functions with respect to x. The first one, x raised to 4 minus 2 sin x plus 3 cos x. Let y be the given function. So dy dx is what? D dx of x raised to 4 minus 2 sin x plus 3 cos x. Use the rules of differentiation. What is derivative of x raised to 4? Derivative of x raised to n is n into x raised to n minus 1. So derivative of x raised to 4 will be 4 into x raised to 4 minus 1. That is 4x cube. Minus 2 is constant. I have written it outside. So what is d dx of sin x? Cos x. Plus 3 into what is d dx of cos x? Minus sin x. You have to put minus sin x in the bracket. Otherwise you may write this as 3 minus sin x. No, it is 3 into minus sin x. So what is the final answer? Dy dx is 4x cube minus 2 cos x minus 3 sin x. The next one, let y be 3 raised to x plus x cube plus 3 cube. Differentiating both sides with respect to x, derivative of a raised to x is a raised to x log a. So it will be derivative of 3 raised to x, 3 raised to x log 3. Derivative of x raised to n is index into x raised to index minus 1. So derivative of x cube will be 3, that is index, into x raised to index minus 1, 3 minus 1, that is 2. And finally, derivative of any constant is always 0. Why? Derivative measures the rate of change. Constant is 1 which does not change. So derivative of any constant will be 0. So what is the final answer? 3 raised to x log 3 plus 3x square. See, you will notice that in derivatives, what is required? You should know all trigonometric formulae. You should be able to apply laws of logarithm. You have to remember two things in calculus. Number one, angle must be expressed in radian only. Secondly, the base of logarithm must be e. If it is not e, you have to change the base to e, as in this case. We are asked to find derivative of log x to the base 3 minus 3 log x to the base e plus 2 tan x. Differentiate. Now log x to the base 3 cannot be differentiated as it is. See, derivative of log x is 1 upon x if base of logarithm is e. If the base is not e, change the base to e using this change of base formula. The only thing is, as base is e, it is not mentioned. So it is log x to the base 3. It is log x to the base e upon log 3 to the base e. This is called as change of base formula. Remaining terms as they are. Now differentiate. Now you may think that you are supposed to use quotient rule here because this is u upon v, but denominator is purely a constant. So I write this as 1 upon log 3 into y, because derivative of constant into function is that constant into derivative of function. Now this is standard formula. D dx of log x is 1 upon x. So here also 1 upon x. And what about derivative of tan x? It is nothing but sec square x. So final answer is dy dx equal to 1 upon x log 3 minus 3 upon x plus 2 sec square x. Now basically the next one is not a problem on derivative, it is a problem on logarithm. In the last step only you have to use simple derivative formulae. Now in this sum, first we write e raised to x log a as what? E raised to log of a raised to x. Why? N log m is log of m raised to n. So all the three terms are written using this result. But note that a raised to log x to the base a is nothing but x. So use this result to get y as what? Simply a raised to x plus x raised to a plus a raised to a. Now these are standard functions. Derivative of a raised to x is a raised to x log a. That of x raised to a is a into x raised to a minus 1. And derivative of any constant is 0. So what is the final answer? Dy dx is a raised to x log a plus a into x raised to a minus 1. Now again this is based on definition of derivative. If f of x equal to cos x, find f dash of x from the first principle and hence find f dash of pi by 4. Finding f dash of pi by 4 is not difficult once you obtain f dash of x, because what is f dash of pi by 4? It is f dash of x at x equal to pi by 4. Now with usual notation fx cos x, f of x plus h, cos of x plus h. What is f dash of x as per definition? Value of this limit. Substitute. Use cos a minus cos b formula. What is that? Minus 2 sine of first angle plus second angle by 2 into sine of first angle minus second angle by 2 and so on. Actually there are two sine terms, right? But this sine term does not require h in the denominator. Why? Because even if you take limit here, then this becomes minus 2 sine x, right? But what about this? If you take limit sine 0, 0, and therefore we require h in the denominator for this sine term. But you will notice that angle h by 2 must be fully repeated in the denominator. So though denominator is h, I write this as h by 2. Effectively, I have utilized these two. So I have written the same but in required form. Now what is limit of product? Product of limits. Now here to take the limit means to replace every h, remember not x, every h by its limiting value, and this is standard trigonometric limit. Its value is 1. So what is the final answer? Minus sine x. But this is f dash of x. We are asked to find f dash of pi by 4. So put x equal to pi by 4. So that gives me minus sine pi by 4, that is minus 1 upon root 2 as the final answer. Now let us solve examples in which rules of differentiation are to be used. First one, root x into cot x. Let y be root x cot x. Differentiating both sides with respect to x, derivative of product is first function root x into derivative of second plus second function into derivative of first. Now what is derivative of cot x? Minus cos x square x. And what is derivative of root x? 1 upon 2 root x. If you rearrange the terms, you get dy dx as minus root x cos x square x plus cot x upon 2 root x as the final answer. Second, 4x square minus 7x plus 5 into sec x. Let y be the function. Now you need not open the bracket. We consider all the three terms in one bracket as first function and sec x as second. So on differentiating with respect to x, What is derivative of product? First function into ddx of second plus second function sec x into ddx of first. What is derivative of sec x? Sec x tan x. Now observe this. What is derivative of 4x square? 4 is constant. Derivative of x square? 2x. Now minus 7x, minus 7 is constant, and what is derivative of x? 1 plus derivative of 5, 0. Now here derivative part is over. If you want to simplify, you can simplify this further to get dy dx as what? 4x square minus 7x plus 5 sec x tan x plus 8x minus 7 into sec x. You can write one more step. You can take sec x common from these two terms. Now third one, let y be x sin x plus cos x plus x cos x minus sin x. Now what is derivative of product? It is first function into derivative of second plus second function into derivative of first. Remember, here we have to use product rule again. I'll explain. What is ddx of x cos x? First function x into derivative of cos x plus second function cos x into derivative of x. In this case also you have to go for product rule. I have written all the steps, so no need of confusion. X into what is derivative of cos x? Minus sin x plus cos x into what is derivative of x? 1 minus cos x as it is. This part, x into what is ddx of sin x? It is cos x, right? Plus sin x into derivative of x, which is 1 minus sin x as it is. Now patiently you have to simplify this. See, up to this only derivative is there, and the next part is simplification. If you simplify, you get final answer as what? X into x cos 2x minus sin 2x. Now why cos 2x? Because cos square x minus sin square x is cos 2x, and 2 sin x cos x is nothing but sin 2x. Actually, if you are asked to find dy dx, you can write answer in any form, but in most of the cases this sum is asked as if y equal to this, show that, prove that dy dx equal to this. Now when we are asked to prove something, obviously we have to prove the same thing. So this is about sum number 3. I repeat, here first you have to use product rule, first into derivative of second, but while differentiating second you have to again use product rule because x and cos x, their product is taken. So x into derivative of cos plus cos into derivative of x and so on. Okay. Now the next one. Now this is product of three functions. Y equal to x square into sin x into log x. No problem. I can consider x square into sin x, this product, as first function. It is possible because a given function can be product of number of functions. So x square sin x is first and log x is second. So what is derivative of product? First x square sin x into derivative of second plus second into derivative of first. Okay. Now what is derivative of this is basically first into derivative of second plus second into derivative of first. Okay, in this case they have obtained the derivative again, that what is derivative of x square sin x? X square into derivative of sin x plus sin x into derivative of x square, which is nothing but 2x. I repeat, x square sin x into derivative of log x is what? It is 1 upon x. Okay, plus log x into what? Derivative of second function. Okay, x square sin x. So on simplification you get this. In fact they have used this result. Y is u v w. Okay, they have used that corollary. y is uvw, then what is dy dx? It is uv into ddx of w and so on. Okay, so this corollary is used. Actually, you can use this result, that consider x square sin x as first function, log x as second function. But in this solution, they have used the corollary, that if y is uvw, then what is dy dx? uv into derivative of w plus uw into derivative of v plus vw into derivative of u. Now what is derivative of log x? 1 upon x. What is derivative of sin x? Cos x. And what is derivative of x square? It is nothing but 2x. So rearrange the terms to get this as final answer. Now sum number 5. Let y be root x plus 1 upon root x minus 1. So it is dy dx, you have to use quotient rule. Denominator root x minus 1 into derivative of numerator minus numerator into derivative of denominator upon denominator square. Now what is derivative of root x? 1 upon 2 root x. Derivative of 1, 0. Here also derivative of root x, 1 upon 2 root x. Derivative of 1, 0. Here derivative part is over. You have to simplify by finding LCM and so on to get final answer as what? Minus 1 upon root x into square of root x minus 1. Now in this sum, again you have to use quotient rule, that dy dx is denominator x log x plus 5, you have to put that in bracket, into ddx of numerator minus numerator into ddx of denominator upon denominator square. What is derivative of x square? 2x. Derivative of 4? 0. Now note that here you have to use product rule. What is ddx of x log x? X into derivative of log x plus log x into derivative of x. Now derivative of log x is 1 upon x plus log x into derivative of x, which is 1. Now derivative of 5 being a constant, 0. Now rearrange the terms. You will notice that final answer is this. So here you have to use both, initially quotient rule and then product rule. Now this is the next one. Again quotient rule is used. Now this is simple because you have to use derivative of x raised to 5, which is 5x raised to 4. Derivative of cos x is minus sin x, and derivative of sin x is nothing but cos x. So this is the final answer. Here you get sin square x plus cos square x, which is nothing but 1. Now this is again a simple one. Application of quotient rule. Denominator into derivative of numerator. What is derivative of e raised to x? E raised to x. What is derivative of 1? 0. What is derivative of x raised to 5? 5x raised to 4. Now e raised to x can be taken common from numerator. See, this is the final answer. Actually this is from 12th standard syllabus, but you should know what is composite function and how to find derivative of composite function. The reason is simple. See, ddx of sin x is cos x. If I ask you to find ddx of sin 2x, it is not simply cos 2x. If you want to find the derivative, again you will have to use definition of derivative, that is first principle. Why? Because sin 2x, or for that matter if I consider sin of log x, this is basically a function of a function, and therefore we discuss derivative of this function of a function, which is called as composite function. Consider the function given as y equal to 8x square minus x plus 15 raised to 9 by 2. Now this function cannot be expressed either as a sum or a difference or product or quotient of functions. But if I put u equal to 8x square minus x plus 15, then I get what? Y equal to u raised to 9 by 2. Thus y is a function of u, where u is a function of x, and in turn y becomes a function of x. So this is a function of a function called as composite function. Now finding derivative of composite function, for that we use one rule which is called as chain rule. See, ddx of x raised to 9 by 2 can be obtained. Similarly, ddu of u raised to 9 by 2 can also be obtained, right? The theorem is, if y is a differentiable function of u and u is a differentiable function of x, then what is dy dx? It is dy du into du dx. See, logic is very simple. Let us discuss chain rule by considering examples. The first one, find derivative of x cube minus 2x minus 1 raised to 5. Had it been x raised to 5, I would have written answer as 5 x raised to 4. But the base is not x, it is other than x. So I replace base by u. Let y be, I begin with, let y be x cube minus 2x minus y raised to 5. So what is u? X cube minus 2x minus 1. So that y becomes u raised to 5. Now y is a function of u. So I can say differentiate with respect to u. Derivative of y with respect to u is dy du. What is derivative of u raised to 5? It is 5 u raised to 4. But we have written u for what? X cube minus 2x minus 1. So dy du is nothing but 5 into x cube minus 2x minus 1 raised to 4. Now what is du dx? If u is x cube minus 2x minus 1, what will be du dx? Derivative of x cube is 3x square minus 2 into derivative of x1, derivative of constant is 0. Now I will say by chain rule dy dx is dy du into du dx. Substitute the values. In short, consider base as u. What is derivative of u raised to 5? 5 u raised to 4. But while writing, you have to write this only, because for convenience we are considering u, into derivative of u by chain rule, that is derivative of what? X cube minus 2x minus 1, which is simply 3x square minus 2. I hope you have understood this. So the initial function sine 2x, I take 2x as u. What is derivative of sine u? Cos u. So cos 2x into du dx by chain rule, that is into derivative of 2x, which is 2. And therefore derivative of sine 2x is not just cos 2x, but it is cos 2x into derivative of 2x, that is 2. So finally ddx of sine 2x is 2 cos 2x. There are some students who think that derivative of sine 2x is cos 2. And what is the logic? Absurd, of course, that they say sine has derivative cos and 2x has derivative 2. No, that is not correct. So how to remember this result? Derivative of sine is always cos into derivative of angle. So what is derivative of sine 2x? Cos 2x into derivative of angle 2x, which is 2. Use same logic for sine a. What is derivative of sine a? Initially you may say cos a, but into derivative of a, angle, which is 0, because a is constant. So ultimately derivative of sine a is nothing but 0. Now actually this is similar example. So I take base as u. What is derivative of u raised to 5 by 2? 5 by 2 u raised to 5 by 2 minus 1, right? That is nothing but 3 by 2 into du dx by chain rule. We have put u for what? Base. Now this is not difficult. Derivative of x raised to 3 by 2 is 3 by 2 into x raised to 3 by 2 minus 1 minus 3. What is derivative of x raised to 4 by 3? 4 by 3 x raised to 4 by 3 minus 1. Simplify. Okay. Now see this one. See, basically, what is derivative of root? Derivative of root is 1 upon 2 root into root of which function? Root of tan. But what is derivative of tan? Sec square. But tan of which angle? Root x. And what is derivative of root x? 1 upon 2 root x. So this is the final answer. I'll explain this once again. This is not y equal to root x. Had it been y equal to root x, I would have written answer as dy dx equal to 1 upon 2 root x. So think tan root x as u. So what is derivative of root u? It is 1 upon 2 root u into du dx by chain rule. We have taken u for what? Tan root x. So into derivative of tan root x. Now tell me what is derivative of tan? Sec square into derivative of angle root x. Now what is derivative of root x? 1 upon 2 root x. We know the standard result that derivative of a, that is base constant, a raised to x equal to a raised to x log a. But index is other than x. So we put or we consider that index as u. So what is ddx of 5 raised to sine cube x plus 3? It is derivative of 5 raised to u, which is 5 raised to u log 5 into du dx by chain rule. That is derivative of sine cube x. Now what is sine cube x? It is cube of sine x. So I consider sine x as, say, v. What is derivative of v cube? 3v square into derivative of sine, which is nothing but cos. So this is the final answer. Now this is generalization of standard formulae. See, we know that derivative of x raised to n is what? N into x raised to n minus 1. Now base need not be x, because I can say sin x raised to 7, right? So in general, if the base is fx, then what is derivative of fx raised to n? Logic is very simple. Suppose fx is u. What is derivative of u raised to n? It is n u. But while writing fx, n u raised to n minus 1 into du dx. Why? Chain rule. So into derivative of fx, which is f dash of x. Same logic is applicable for other functions also. I will explain this. Sin fx. Put fx equal to u. So what is derivative of sin u cos u, where u is fx, into du dx by chain rule. So into derivative of fx, that is derivative of fx, which is nothing but f dash of x. One example. What will be derivative of sine of log x? Derivative of sine is cos. So cos of log x into derivative of log x, which is 1 upon x. So I have mentioned all the 13 standard formulae, but instead of x, I have considered f of x. So this is the end of the lecture on derivatives. In the next lecture, we will discuss the topic integration. Thank you.